The Egyptians had what I consider kind of a neat little system for multiplication. There's a lot of insight here, and it's really pretty clever. For example, let's say we want to multiply 6 by 14. The first thing we do is we make a table. We say that 1 14 is 14. 2 14s is 28. 4 14s is 56. Now if we want to do 6 times 14, we add 2 14s to 4 14s, giving us the sum of 28 and 56. Now of course we have a multiplication algorithm that works more efficiently than that, but in the Egyptian algorithm, okay, 14 is going to be indicated as a heel bone and 4 tally marks. 28 will be 2 heel bones. And we don't have to think 28, we just look at what we've got here and double it. Now if we double this, we're going to end up with this many tally marks and this many heel bones. There are too many tally marks here. We've got 10 tally marks here, which will make a heel bone. So we're going to say, okay, now we've got this many heel bones, and we're going to have 6 tally marks left over. Now we know that we want to make up 6 of these, and we know that if you double this number here and then double it again, we're going to get double the number and then 6 times the number. So that we're going to end up adding this number and this number, which will end up giving us, well, we're going to have, if we just take the first 2 of these and put them together with these, it's going to give us a heel bone. So it's going to be a heel bone plus what's left over down here, the 4 that we have left over, in addition to all these heel bones there, this many and this many heel bones. And that's going to be equal to this many heel bones and this many strokes. And again, I'm afraid that I went off the screen. Again, I'm not sure why that's happening, but the view I have here has me on the screen, and I just noticed the view in the computer doesn't. So I apologize for that, but you see I've just taken this number and added them together. Okay, the 8, 9, 10 makes a heel bone, and the 4 left over will be strokes. We just add the heel bones here, and we get the total. And of course that could be written as 6 tally marks multiplied by, I don't know what symbol they use for multiplication, but multiplied by a heel bone plus 4 tally marks. It's going to be this and this, and we put these 2 together, and again we get the same result as we obtained before. I'm going to zoom back slightly and move just slightly to the right here so we maybe avoid the problem we've been seeing. Okay, now if we wanted to do 11 times 24, in our system we would see that as being, well, to make up 11, first of all we do the doublings. We got the 24, we double that, we get 48, we double that, we get 96, we double that, we get 192. We could also double using the Egyptian symbols, and it wouldn't be that inconvenient. Now 11, in order to do 11, how many do we need? We need 8 and 2 and 1 24s. So we see how many 24s we need, and then we simply do the calculation. That sum would be 24 plus 48 plus 192 in our system. And then I'm not going to actually work that one out in the Egyptian system, but you could do something very similar to what I did up here.